Alright, so a couple things here. One is after these notes there are only 7 notes left. So I'm trying to throw that out there to kind of motivate you to power through this stuff. Only 7 left when we finish these notes. Okay, next thing is that we want to focus on the integral of 1 over y dy is the natural log the absolute value of y plus c. Not, don't think of it as y to the negative 1 dy. Because then you might want to try to use the power rule where we add 1 to the exponent divided by the new exponent. Try to focus on it as 1 over y maybe. Or as long as you understand that this is this and you don't try to use the power rule, I don't even know if that's what it's called, power rule, but whatever, when we add 1 to the exponent divided by the new exponent, don't do that. Okay, now what we're going to do on this first example is basically separation of variables, and we have a whole lesson on that coming up in our next lesson, but it's here, so we're going to do it, introduce it now anyway. So the first thing, when you see solve a differential equation, you want to focus on these 3 steps: separate, integrate, evaluate. So in the separate process, if they write it as y prime, we want to switch that to dy dx. Alright? And so that first step is just to get the y's on one side and the x's on the other side. So here, the dy is on the left, so we're going to divide by y squared. So that's be 1 over y squared. But that we can use the power rule on. So that's fine. And then we'll multiply both sides by dx. So hopefully you can make sure that you understand what happened there. Okay? So in this case, because it's not to the negative 1, I want to focus on the power. So like that. So step 2, so I did step 1 in blue, separate. Step 2 is to integrate. So we're going to add 1 to the exponent and divide by the new exponent. So that's going to be negative. And then on this side, we're going to add 1 to the exponent and divide by the new exponent. So we're going to have negative 4 divided by 2, so that's going to be negative 2. And then technically we would have a plus c over here and we'd have a plus c over here, but then we would take this c, whatever it was, and take the opposite of it and put it over here. And so we don't want 2 plus c's on there, it's just extra. So we're just going to do that. Okay? Now, the next step is to evaluate for c. So they give us a coordinate over here. So this coordinate is 0, 1. So if we plug that in here, it would be negative 1 over 1, technically, which is just negative 1, but still. And then here we have negative 2 times 0 squared. So that's 0. So we get that c equals negative 1. And so then, if we wrap that up, we go back to here and plug the negative 1 in. So this was negative 1 over y. And then we have negative 2x squared minus 1. So what we can do there, first of all, we can see maybe take that whole thing and multiply it by negative 1. That's going to make all 3 of those positive, so that would be nice. And then what we could do is, trying to think of the easiest way to show this, maybe multiply both sides by y. So that would be y times 2x squared plus 1, because we multiplied that all by negative 1, so they all became positive. And then we multiplied both sides by y, and we're almost done here. We're going to divide both sides by this. So our final answer is going to be 1 over 2x squared plus 1. And that's a pretty important process because it's usually a free response question on the AP test, and it counts for 4 or 5 points. So extremely important question here. Extremely important that we understand that process. Okay, and we're going to work on that more in the next lesson, 5.7. But for now, the rest of this lesson, we're going to focus on exponential growth and decay models. Okay, and so this kind of describes in here, and I've highlighted some things you want to focus on. So sometimes in the wording of the question, they'll talk about the rate proportional, and that's kind of this differential equation right here. And that's a differential equation because it has a derivative in it. K is a constant, so we don't want to get distracted by that. And then this is basically this is our PERT formula. If you look at it, it's kind of the same, right? P, E to the RT, pretty similar. So it's not like that's some crazy new formula. The initial value is what we started with. K is the constant of proportionality. If K is greater than 0, then we have growth, and if K is less than 0, then we have decay. So that's probably something that would be good. Highlight that, but make sure you understand the difference between growth and decay there. Okay, so if we take the derivative of this, that would be y prime. And if we take the derivative of this, we're going to have c as a constant. So if we take the derivative of e to the u, you get e to the u times du. Well, the derivative of that exponent is just k. So we would have that. Now if we go back and look, this is what we started with. It's the same thing, which is y. So we get that y prime is equal to y times k, which we could flip around using symmetry. And so that shows that we do get that. Okay, so now, when we are asked to do these problems, we are going to go through this kind of three-step process. So the first thing we want to do is focus on finding c. The second thing we want to do is focus on finding k, and then we can find the answer. So I'm going to color code that here, and we'll do that. And so when you see this wording, the rate of change of y is proportional to y, then that's kind of telling you that we can use y equals ce to the kt. That's an e. Alright. So the first thing we're going to do is they're pretty much going to give you 0 every time, because what that's going to allow you to do, so y is 3, and what does it say? T is 0. So you're going to have 0 times k, right, which is going to be 0, and e to the 0 is going to be 1. So by giving us the times 0, they're always going to allow us to find c right away. Okay, now step 2 is to find k. So they're going to give you another point. So I'm going to just go ahead and plug that in directly. I guess I could have started with the little equation, but that's 5. And we already found out that c was 3, so that goes there. And then e to the k and t is 3. So we have everything except for k. Remember, e is not a variable, it's a constant. So we can divide both sides by 3. And then what we want to do is take the natural log of both sides. So if we take the natural log of that, and we take the natural log of this, and the reason we wanted to do that was because now the natural log of e, these are inverses of each other. That's going to cancel out. So we just get 3k equals this. So if we multiply both sides by 1/3, we find out that k equals 1/3 times the natural log of 5/3. So that works out pretty nicely. And now, what we want to do with that, though, is we want to store that. So we would have that on our calculator. We would want to store that into a, because when we come back to do our answer here now, so then it says, what's the value of y when t equals 4? So y equals, we already found that c was 3, e, and we found out that, I'm going to write it as a. K is equal to a, which we have stored in our calculator. I guess we could have stored it in k, but I usually just store everything in a. And then t is 4, so we have a times 4. So this should be, if you stored that in a, you can just type the letter a, and then that will give you your answer on the calculator screen. Would be a good idea, as I've said before, to type that in and make sure you get the same thing. Alright, so now would be an excellent time to kind of pause this and see if you can do it. Now this is a little bit different, but so our first step is to find c. But in our problem, c is actually the initial amount, and that's what they gave us immediately. So not really anything to do there. So step 2 is to find k. Now, to find k, we already did that in the last notes, if you remember that, in negative 0.00012, something like that. But if you don't have that memorized, we can figure it out really easily right here, because let's just say that when that happens one time, this is what we're looking at. So we have kt. So k is right there, and t is going to be 5,730. Right? What's the formula? Y equals ce to the kt. So if the half-life has happened one time, we know that 5,730 years have passed, and our 10 went to 5 because the half-life happened once. Okay? So if we divide both sides by 10, we get 1/2 or 0.5. And then we're going to take the natural log of both sides like we did there. So we have the natural log of 0.5. And then here, this side, it's going to cancel. So that's going to leave us with 5,730 times k. If we divide both sides by 5,000, so k is equal to the natural log of 0.5 divided by 5,730. And if you type that in your calculator, that's going to be negative 0.000121 ... Okay, so we want to store that in, I would just store it in A. Now, let's think about this for a second. K is negative, so K is less than 0. So this is a decay situation. It's radioactive decay. The amount of stuff that we have is going to be less. So that's one way we can tell. We're going to have less, we're going to have more. Well, if k is negative, we're going to have less. If k is positive, we're going to have more. Okay? So, we did a problem similar to this, well, a little bit similar. It gave us years or something. This time they're giving us the grams. So they're giving us the ending amount. So we have 7. Okay, and the starting amount was 10, and we have E and A, we already have, is over here. And the question they're asking us to solve is solve for T. Eat. Hey, that spells eat. Okay. Anyway, that's not relevant to anything that we're doing, but I just noticed that. Okay, so we're going to divide both sides by 10. So that's going to give us 0.7851. And then we would take the natural log of both sides, because we take, so this is gone, we take the natural log of E, that their inverses cancel, so that's A, and A is stored in our calculator, so we're going to just take that divided by A, so you'll type that in, divided by A, enter, and then you will get that is about 2,000, oops, that's a 0. So about 2,000 years, actually. Okay, so we're about halfway done here. Just 2 pages today. That's page 1. Okay, and here's page 2. So we're only doing 3 examples here, actually. Example 5 is in your textbook on page 364, and you can look at that for a little bit more information. Okay, so let's see here. 5,098,000,000, 5.9 billion, 6.9 billion in 2011. Okay. Approximately how many people were there in 1990? So, let's see. 98 to 2011. So there's a couple different ways we could do this. So, we're actually going to be solving for C in the end. Okay, so here's how I want to do this. I'm going to use these first 2 coordinates, basically, to find K. So we ended up with 6.9 when we started with 5.9. And that's E to the K times, and the time between there, 2011 and 1998, is 13. So T will be 13. There are other ways to do this, so if you think of another way, that's okay too. Your answer should be really close to mine if you do it another way that also works. Okay, so fine. We've done this process a few times now already, so that natural log of both sides, so we're going to have the natural log of 6.9 over 5.9. Natural log here cancels that out. We're going to have, I guess I could do that, 13k. And then we're going to divide both sides by 13 or multiply by 1/13. So I guess I could just leave the decimal. I'll put 69 over 5.9. I mean, two less things to write, but it's not a big deal. Okay, so store that into A. Now, if we move over, we have that value of K. Now what we can do is we're trying to find how many people in 1990. So since these are closer, okay, that's 8 years apart, and this is 21 years apart. That's 8 years. This would be 21 years. So the data is probably more accurate, closer to the same time frame. So we're going to use these 2 points here. So now we're going to say that this was the ending amount. So we're going to kind of change how we're looking at that, and we're trying to find the starting amount. And A we have stored in our calculators, and then that gap is 8 years. We just talked about that. So 8 years is closer than 21 years. So now, actually, we just need to divide both sides, e to the 8a. Probably make sure if you're typing that in your calculator, you put parentheses around that. And we get that is 5.358 billion people. Okay, now to wrap these, and you can pause that if you need to look at that. But so to wrap this up, we're going to talk about Newton's law of cooling. Now, normally in the AP exam, if they ask you a Newton's law of cooling question, they just give you the formula, and you're kind of just plugged into it. But I'm still going to show you a little move that we can make here, and we'll see what happens. So if we were to start off with this, so we're just going to do this one time, then I'm going to show you how to answer it with what we do here, and then we'll answer it with this again. So, and when we finish this first part, you can just memorize that to do these. So what we're going to do is switch this formula to y equals c e to the kt, which is the same formula we already have, plus the ambient temperature, the environmental temperature, the temperature around whatever it is. That obviously the temperature around something affects how fast it heats up or cools down. That's why we put something in the oven. We turn the temperature up in the oven and we put the stuff in there, and then that's what we're cooking it. All right. To look at this first, if we take this, this is going to be dy dt equals, and we have k times, and we'll do this for this problem. So we put a hot potato in a pan under running water that's 20 degrees Celsius. So that would be y minus 20 minus e, ambient temperature, using this formula here. Okay, so if we separate the variables, then we would divide both sides by y minus 20 to get that with the dy's over here, and this side would be k dt. Okay, so that was step one, was to separate, and we're only going to do this one time because then we'll know the formula. Then we're going to integrate both sides. And we integrate both sides. This is going to be the natural log of y minus 20. And this is going to be kt plus, and we're going to put c1 because we're going to get some other c's along the way. So we're going to do that. Then remember, step 3 was to evaluate. Integrate, separate, integrate, evaluate. So now we're going to evaluate for C. So the first thing we want to do is you could solve for C now, but I'm going to simplify this a little bit. So if we do this, that's going to cancel out. Now this is always going to be positive anyway, so y minus 20. And then here we're going to have, now this is a little bit, this is always positive. Sorry. This is always positive. Always positive. So since this is always positive, we don't need the absolute value on there, so we can drop it because this will be a positive number. Now there's a little trick here. So if we have a base and we're adding the exponents, what we could have had before that was two things of the same base multiplied by each other. Okay, so if you think about that, let's say this is e to the kt times e to the c1. Because if we multiply two things of the same base, we add the exponents. Okay, and what we can do here is e to the c is its own constant. So what we can do then is y equals, and that will become its own c. And now I can just put c because I used c1 for that one. So e, if this is blowing you away, don't freak out about it too much. Okay. So this is the only time we're going to do that, because now we have that formula right here. And we can just go straight into that formula. So let's go through our process. So our process is to solve for C. So if we're going to do that, so our basic formula, we're going to start right there. So that's CE to the KT plus 20. Alright. Now, at 100 degrees, so we're going to plug in 100 for Y, and we're trying to solve for T, and E and 0 at, that's when we're starting. So that's K times 0 plus 20. So that equals 1, and we subtract 20 from both sides, we get that C is equal to 80. Alright, so now we know that C is equal to 80. So remember, the next step is to calculate K. So, let's see here. What does it say? It says after 6 minutes, now it's 40 degrees. Okay? So, this is now 40. We found out that C was 80. E to the K 6 after 6 minutes, and plus 20 over here. So if we subtract 20, we get 40 minus 20 is 20. So we would have 20, and then divide by 80, and then take, okay, am I doing too much at the same time? Maybe. Okay, so subtract 20 and divide by 80. Now, take the natural log of both sides. So now we have the natural log of 0.25. This is gone, that's just 6k, so I'm going to divide by 6 or multiply by 1/6. So that's k, and we want to store that in A. Okay, so we found C here. This is separate. This was just to get us this formula right here, which is what I use from now on. They may give you a formula in the problem, then you just use that. Okay, so we found C, we found K, and now we want to evaluate for the final answer. So how long will it take the potato to reach 25 degrees? So we have 25, 80, E to the AT, because A is right here, plus 20. So subtract 20 over here, we're going to get 5, and divide by 80. And I want to take the natural log at the same time as well, but natural log of both sides. So that's going to cancel, and I can probably think I'm doing too much. Okay, so that's 1 over 16. And this is a times t. So t is equal to 1 over a times the natural log of 1 over 16. And so if you do it in the calculator, that turns out to be 12.000 ... minutes. Now, there's this really tricky question. It's very annoying. How much longer after the 6 minutes? So what we need is the 12 minus the 6. So maybe we could say 12 minutes total, but 6 minutes longer after that other measurement. So that's just a reading comprehension question. I don't like that. I don't like that a student would miss a point because they didn't read that carefully, but they have had that on there, so that's why we're emphasizing it. So now we want to do the same. Well, I'm sure we don't want to, but we need to finish this up. Last example. We don't need to do this again. We have the formula, so now we're just going to do this part. Okay? So it would be nice if you would try to do it without looking at this. So step 1 is y equals CE to the KT plus the ambient temperature. Okay, so there is the ambient temperature, 70 degrees. Okay, so the cup of coffee starts off at 180. So we have 180 equals, and remember step 1 is to find C, and we're starting off our starting off time, so that's 0. So that's going to be 110. So C is 110. Now I could do one more step here and actually write that out as the equation so far. So I could have done, I didn't have a lot of space up there. So that's where we're at right now. We found C. Okay. So step 2 is right here. So that's when we take the other piece of information. So here's where the 2 minutes and the 165. So after 2 minutes, it's 165. So we found C was 110, so there's the formula, and E, and 2 minutes, so that's K times 2, and plus the 70. So if we subtract the 70, we're going to get 95, and if we divide by 110, we'll get that. And then we have e to the 2k, and we take the natural log of both sides, and so we end up with k equals, this is gone, multiply both sides by 1/2. So here's the exact value, and then we will type that into the calculator to get the decimal value to use. Okay. You never want to use a rounded off number until your final answer, not during your calculations. Alright, and so we are almost done here. So, again, trying to hopefully do it maybe without looking at that too much. So the final question here is, how long is it going to take to get how much longer again? So, and be careful, it might not be how much longer, it just might be how long did it take. So you just have to make sure you read carefully and see what they're trying to find. So 120 and 110 e to the at, eat, plus 70. So that's 50 over 110, or 5 over 11 actually, e to the at, natural log, both sides, so 1 over a, natural log 5/11, that's t, and so if we type that in, it is 10.756, and how much longer than the 2 minutes? So take the 2 minutes off, 8.756 minutes longer after the 2 minutes. Bam! It is about that time. Have a good day. 7 notes left, or lessons.